Hello students, here in the seventh part of the video, I'm going to start ideal and non-ideal solutions. Now, as on the basis of Raoult's law, the liquid-liquid solutions can be classified as ideal and non-ideal solution. So first of all, we will discuss about ideal solutions. Now, according to Raoult's law, the ideal solutions are those solutions which obey Raoult's law over the entire range of the concentration. So such type of solutions are known as Raoult ideal solutions. Other important properties of ideal solutions are the enthalpy of mixing of pure component to form a solution is zero. That is, the change in mixing, the change in enthalpy on mixing for ideal solution is always equal to zero. Similarly, the second property, important property for ideal solution is the volume of mixing is also equal to zero. It means the change in volume on mixing will also be equal to zero for ideal solution. And there is a condition for ideal solution that such solutions are ideal solutions are those solutions which are formed by mixing of the component of two components which have identical molecular size, structure and almost identical intermolecular forces. So such type of solutions which are made up by this type of condition are always form ideal solution. Now, as for ideal solution, the delta H mixing equal to 0. It means that no heat is absorbed or evolved when the components are mixed. Similarly, for ideal solution, delta V mixing is equal to 0. What does it mean? It means the volume of solution would be equal to the sum of volumes of two components. Suppose we have two liquids and we have to mix two liquids. Suppose the volume of one liquid is 50 centimeter cube. Similarly, the volume of second liquid is 50 centimeter cube. Now, on mixing, when we mix these two liquids, liquid 1 and liquid 2, what we will get? We will get the volume of the solution up to 100 centimeter cube. It means when two liquids get mixed, the change in volume on mixing does not get changed. So such type of solutions are known as ideal solution. Now, a perfectly ideal solution is a rare, but some solutions are nearly ideal in their behavior. So this is all about ideal solution. As ideal solutions obey Raoult's law, so for ideal solution, the partial pressure of component 1 will be equal to the partial pressure of pure component and its mole fraction. Similarly, for component B or component 2, the partial pressure of component B will be equal to the partial pressure of pure component B and multiplied by its mole fraction. Now, for ideal solution, the total pressure of the solution will be equal to summation of the partial pressure of two components or two liquids which is present in the solution. So this is all about ideal solution. Now, at molecular level, the ideal behavior of a solution can be explained by considering two components A and B. Suppose in a liquid we have two components and these components are component A and component B. In pure components, the intermolecular interactive interactions between will be the types of AA or BB types. Whereas in a binary solution, the interaction will be as AB type. If we are talking about the pure liquid, if we are talking about only for liquid A, the interaction will be the in between the molecules of A. So the interaction is AA type. If we are talking about component B, then the interaction will be BB type. And if A and B get mixed and they form a solution, then if we are talking about the molecular interaction of the solution, then we are talking about the intermolecular forces between the molecule A and the molecule B. Now, in ideal solution, when these two liquid get mixed, then what happen in ideal solution, the intermolecular attractive forces between AA and BB type molecules are nearly equal to those of the solution, means to those of the AB type molecules. This leads to the formation of an ideal solution. So when the intermolecular interaction of solution particles are nearly equal to the intermolecular interaction of the individual particle or the pure component, then such type of solution formed are known as ideal solution. There are some examples of ideal solutions. Ideal solutions can be a mixture of N-hexane and N-heptane, mixture of bromoethane and chloroethane, mixture of benzene and toluene. Such type of mixtures are known as ideal solutions. Now the next solution is non-ideal solution. When a solution does not obey Raoult's law over the entire range of concentration, then it is called non-ideal solution. Opposite to the ideal solution obeys Raoult's law, whereas a non-ideal solution does not obey the Raoult's law entire range of concentration. So as the solution does not obey Raoult's law, what does it mean? It means the value of partial pressure of component A will be not equal to its multiplication of its pure component and its mole fraction. Similarly, for component B, partial vapor pressure of component B will be not equal to the partial vapor pressure of pure component B and its mole fraction. If the partial pressures are not equal to their mole fractions, so the total pressure of the solution will not be equal to the sum of partial pressure of the individual components. So if the solution has such type of property, it means it does not obey Raoult's law and their vapor pressures are not equal to their mole fractions. So such type of property can be shown by the non-ideal solution, or we can say that such type of solutions are known as non-ideal solution. Similarly, as in ideal solution, we have discussed other important properties of ideal solution, that for ideal solutions the delta H mixing equal to 0. Similarly, delta V mixing is also equal to 0. But now the non-ideal solution are just opposite to the ideal solutions. So for non-ideal solution, the value of delta H mixing will not be equal to 0 and the value of delta V mixing will not be equal to 0. If these values are not equal to their respective component, so what does it mean? It means that either the values will be greater than 0 or the values will be less than. As the partial pressure of component A is not equal to its mole fraction according to Raoult's law. According to Raoult's law, it should be equal, but non-ideal solution does not obey Raoult's law. So for non-ideal solution, the partial pressure of component A is not equal to its mole fraction. What does this mean? This means that the partial pressure either greater or less than its mole fraction. नॉट इक्वल का मीन्स ही क्या है? या तो ग्रेटर होगा साइन उसका, या फिर उसका साइन क्या होगा? लेस होगा. सो जब यहाँ से जब वो दो पार्ट में डिवाइड हो गया, जब वैल्यूज इक्वल नहीं आई नॉन आइडियल सॉल्यूशन की, तो अब हम या तो वैल्यू ज़्यादा होनी है या फिर वैल्यू कम होनी है. तो इस तरीके से हम नॉन आइडियल सॉल्यूशन को डिवाइड करते हैं दो पार्ट्स में. नॉन आइडियल सॉल्यूशंस नाउ डिवाइडेड इनटू टू पार्ट्स. One part is known as non-ideal solution showing पॉजिटिव डेविएशन, दो पार्ट्स में डिवाइड हो जाता है नॉन आइडियल सॉल्यूशन यहाँ पे। एक होता है पॉजिटिव डेविएशन जहाँ पे वैल्यू ग्रेटर होंगी, एक होगा नेगेटिव डेविएशन जहाँ पे वैल्यू लेस होंगी। So first of all we will discuss the positive deviation of non-ideal solution. Now in case of positive deviation from Raoult's law, what happens? The interaction between AA particles, the interaction between AA and BB particles means the interaction of individual particles are more as compared to the interaction between the particles which are present in the solution, mean as compared to the particles of A-B type interaction. It means for positive deviation the interaction between AA or B type particles means individual particle interaction, individual particles has more interaction, more intermolecular interaction as compared to the interaction of solution particles. So अगर हमारे पास में इंडिविजुअल पार्टिकल का इंटरेक्शन ज़्यादा हो गया सॉल्यूशन के पार्टिकल से, तो सॉल्यूशन में जो पार्टिकल्स हैं उनकी जो बाइंडिंग कैपेसिटी है वो क्या हो जाएगी? लेस होगी, क्योंकि उनका इंटरेक्शन बहुत कम है, उनका इंटरमॉलिक्यूलर इंटरेक्शन बहुत कम है। तो जो सॉल्यूशन के जो पार्टिकल है ए बी टाइप के जो पार्टिकल है इनका इंटरेक्शन क्या होगा? बहुत कम होगा। अगर इनके मॉलिक्यूल्स के बीच में ही इंटरेक्शन कम है तो ये क्या करने लगेंगे? स्केप करने लगेंगे अपने सॉल्यूशन से। एज दे स्टार्ट स्केपिंग, after escaping to their vapor phase, what will happen? They generates more vapor at their vapor phase. जैसे ही अपने वेपर फेज में पहुंचे स्केप होने के बाद, तो ये वेपर फेज में बहुत सारी वेपर क्रिएट करेंगे, क्योंकि स्केप हो रहे हैं तो वेपर क्रिएट होती रह रही है वेपर फेज में। एंड एज क्रिएटिंग द वेपर एट वेपर फेज, द वेपर प्रेशर इंक्रीजेस। ऑन increasing the amount of vapors at vapor phase, the vapor pressure also gets increases. And as the vapor pressure get increases, the resultant solution will show a positive deviation. ठीक है, वेपर प्रेशर इंक्रीज हो जा रहा है, इसी वजह से क्या हो रहा है? जो रिजल्टिंग सॉल्यूशन है वो कैसे कन्वर्ट हो जा रहा है? पॉजिटिव डेविएशन की साइड को जाके कन्वर्ट हो जा रहा है। ठीक, नाउ अकॉर्डिंग टू दिस, अब जो वैल्यू है डेल्टा एच मिक्सिंग जो था हमारे पास, जो हमारे पास डेल्टा एच मिक्सिंग की वैल्यू है नॉन आइडियल सॉल्यूशन शोइंग पॉजिटिव डेविएशन, इट विल बी ग्रेटर देन 0 एंड द प्रोसेस इज एंडोथर्मिक इन नेचर। नाउ similarly delta V mixing will also be equal to also be greater than 0. Why? Because as the interaction between the solution particle is less, so the molecules of solution will get escaping, and as they get escaping, the volume of the solution will be increases, and as the volume of the solution increases, so the change in volume of mixing will be greater than 0. This can be further shown by a graph. Here these dotted lines shows the graph for ideal solution, whereas when there is a deviation present in ideal behavior of solution, then as the deviation is positive, the interaction of the solution particle is weaker. As the deviation is positive, so the graph will move towards the positive side. This solid blue lines represent the positive deviation from the ideal behavior of a solution. This is these dotted green lines shows that the solution, graph for ideal solution, and where there is a deviation from ideal behavior of a solution, and the behavior is positive, then this lines will be converted towards positive side. They converted towards positive side, they deviated towards positive side. So the example for non-ideal solution showing positive deviation, that is the mixture of ethanol and acetone. In pure ethanol, molecules shows hydrogen bonding. Clear? As we have pure ethanol molecule, the molecules of pure ethanol C2H5OH, C2H5OH, they shows hydrogen bonding between them. On adding acetone to ethanol, its molecules get in in between the host molecules and break some hydrogen bonds between them. The hydrogen bond which are forming between the ethanol molecules, as we add acetone to that, those hydrogen bond can break to some extent and the host molecules will get attached. Now due to weakening of interaction, the solution shows positive deviation from Raoult's law. But the molecules of acetone and ethanol which are present in the solution, they have very weak interaction. And as they have very weak interaction in the solution part, their molecule will escape to their vapor phase. And as they escape to their vapor phase, the vapor on the vapor phase will be more, and due to this the vapor pressure increases. On increasing the vapor pressure, the solution will show positive deviation of Raoult's law. Now come to the next. If it is lower, it exhibits negative deviation from Raoult's law. Now, in case of negative deviation from Raoult's law, the intermolecular force of attraction between pure component AA and BB are weaker. Now, it is opposite from positive deviation. In positive deviation, the intermolecular forces of attraction between pure component AA and BB are stronger, but here in negative deviation, the intermolecular interaction between AA and BB are weaker, and those between the solution particles between A and B leads to decrease the vapor pressure, resulting in negative deviation. Now what happened, let's see. As the intermolecular interactions of pure component, that is interaction between AA particles and interaction between BB particles, are weaker as compared to the particles of solution, that is, it means the interaction between A and B. So as the interaction of solute particle are more, so the escaping tendency of solute particle will be less, because they are more tightly connected with each other. So their escaping tendency will be less. As their escaping tendency is less, as they less escaped, so their vapors in the vapor phase will also get reduced. As their vapor get reduced, their vapor pressure will be decreases, and on decreasing the vapor pressure, the ideal behavior, the Raoult's law shows negative deviation, means in negative direction. So as it shows negative deviation, it means the delta H mixing for such type of solution will also be less than 0, means towards negative side, and process will be exothermic in nature. And similarly delta V mixing will also be equal to 0, because the escaping of molecule is less, and as they are bounded close to each other, so their volume gets decreased. As they escape less, their volume gets decreased. हमारे पास में कोई दो कंपोनेंट हैं, हम सॉल्यूशन में मिक्स करने से पहले दो कंपोनेंट थे, कंपोनेंट ए एंड कंपोनेंट बी. ए और ए के जो पार्टिकल्स हैं उन्हीं के बीच में बहुत ज्यादा इंटरेक्शन है, तो वो कैसा बिहेवियर शो करेगा? पॉजिटिव डेविएशन का. अगर ए और ए के पार्टिकल्स के बीच में ही इंटरेक्शन कम है, और सिमिलरली ए और बी के पार्टिकल्स के बीच में ही इंटरेक्शन बहुत कम है, मतलब अगर हम इनको सॉल्यूशन में मिक्स करते हैं तो ये इजीली सॉल्यूशन में मिक्स होने को तैयार है, ये इजीली सॉल्यूशन बनाने को तैयार है. हमने इन्हें मिक्स करा तो इन्होंने एक सॉल्यूशन बना दिया. ए बी टाइप ये सॉल्यूशन प्रिपेयर कर रहे हैं सॉल्यूशन में जाके, तो इनके बीच में ही इंटरेक्शन बहुत कम था, तो इन्होंने इजीली सॉल्यूशन प्रिपेयर करा. एंड जैसे ही इन्होंने इजीली सॉल्यूशन प्रिपेयर करा, तो इनके जो सॉल्यूशन का अब जो इंटरेक्शन है, अब ए और बी के बीच का जो इंटरेक्शन है वो बहुत ज्यादा हो गया. इंडिविजुअल में तो इनके खुद का तो इंटरेक्शन कम था, बट इनका ए और बी के साथ इंटरेक्शन बहुत ज्यादा हो गया. अगर इन दोनों का ही सॉल्यूशन में इंटरेक्शन ज्यादा होगा, तो ये मॉलिक्यूल अपने वेपर फेज में कम स्केप करेंगे, क्योंकि बॉन्ड क्लोजली बाउंडेड है. अगर ये कम स्केप करते हैं तो इनकी वेपर्स क्या हो रही है? कम फॉर्म हो रही है वेपर फेज में, एंड एज वेपर्स कम फॉर्म हो रही है तो वेपर प्रेशर विल गेट डिक्रीज. और अगर वेपर प्रेशर कम हो जा रहा है तो इसका मतलब ये है कि जो राउल्ट्स लॉ है वो कैसा डेविएशन शो करने लग गया? नेगेटिव. आइडियल तो बिहेवियर था, लेकिन अब बिहेवियर कैसा हो गया? अगर उसने सारी चीजें कम हो गई, उसकी लेस देन 0 हो गई, तो बिहेवियर कैसा शो करने लगा? निगेटिव बिहेवियर शो करने लगेगा. दिस कैन ऑल्सो बी एक्सप्लेन विद द हेल्प ऑफ दिस ग्राफ, vapor pressure versus mole fraction. Again, this dotted lines, green dotted lines are for ideal solution, and as the behavior of intermolecular forces changes, the graph will deviate towards negative side. Here it is. So this will show the negative deviation from Raoult's law. Now the examples which are showing negative deviation from Raoult's law are a mixture of phenol and aniline. In this case, the intermolecular hydrogen bonding between phenolic proton and lone pair of nitrogen atom aniline is stronger because they are forming a solution. Phenolic proton and lone pair of nitrogen is stronger than the respective intermolecular hydrogen bonding between similar molecule. सिमिलर मॉलिक्यूल की बॉन्डिंग के कंपैरिजन में उनके सॉल्यूशन की बॉन्डिंग ज्यादा है, इसीलिए वो कैसा बिहेवियर शो करने लगा? निगेटिव डेविएशन का बिहेवियर शो करने लगा. एक चीज और, जिनके सॉल्यूशन की बॉन्डिंग बहुत ज्यादा होगी वो सॉल्यूशंस हमेशा निगेटिव डेविएशन शो करेंगे. जिनके सॉल्यूशन की बॉन्डिंग लेस होगी, जिनके सॉल्यूशन के पार्टिकल्स की बॉन्डिंग लेस होगी, वो पॉजिटिव डेविएशन शो करेंगे. वन मोर एग्जाम्पल, अ मिक्सचर ऑफ क्लोरोफॉर्म एंड एसीटोन forms a solution with negative deviation from Raoult's law. This is because chloroform molecule is able to form hydrogen bond with acetone molecule, and hydrogen bonds are stronger bond in nature. As chloroform molecule forms a hydrogen bond with acetone molecule in a solution, so we can't break the bond again, and hydrogen bonding is stronger, their molecules can't escape to their vapor phase more. They will escape, but in their less tendency. So this is all about negative deviation from Raoult's law. This can be further shown in this image, that this is the ideal mixing where number of interaction of solution particles is equal to the number of interaction of individual particles. Here, this is ideal mixing. If this ideal mixing gets deviate, so if the interaction between solute and solvent, if the interaction between A and B is weak, then what will happen? They will show positive deviation. Why? Because escaping tendency क्या हो जाएगी? सॉल्यूशन से मॉलिक्यूल की ज्यादा हो जाएगी. अगर escaping tendency ज्यादा है तो वो वेपर फेज में आके कलेक्ट हो गए, और वेपर फेज में आके अगर कलेक्ट हो रहे हैं तो उनका वेपर प्रेशर क्या, जितने ज्यादा मॉलिक्यूल्स वेपर फेज में होंगे उतना ही ज्यादा वो प्रेशर अप्लाई करेंगे, तो उनका वेपर फेज प्रेशर क्या होगा? इंक्रीज कर रहा है यहाँ पे. ठीक, तो ये क्या शो करेगा? पॉजिटिव डेविएशन. एंड इन दिस केस डेल्टा एच मिक्सिंग विल बी इक्वल ग्रेटर देन 0. सिमिलरली डेल्टा वी मिक्सिंग विल ऑल्सो बी ग्रेटर देन 0. नाउ सेकेंड केस, आइडियल मिक्सिंग में ही डेविएशन हुआ, और ऐसा डेविएशन हुआ जो इंटरेक्शन है सॉल्यूशन के पार्टिकल्स का, डेट इज ए एंड बी, वो बहुत स्ट्रॉन्ग है. तो वो जो डेविएशन शो करेगा, वो कैसा डेविएशन शो करेगा? डेट विल शो निगेटिव डेविएशन. एंड इन निगेटिव डेविएशन जो इंटरेक्शन है सॉल्यूट एंड सॉल्वेंट पार्टिकल्स का वो बहुत ज्यादा है. ए और बी के बीच का इंटरेक्शन बहुत ज्यादा है. अगर वो ज्यादा होगा तो जो स्केपिंग है टेंडेंसी, वो बहुत कम अमाउंट में स्केप करेंगे अपने वेपर फेज में. यहाँ पे कम अमाउंट शो हो रहा है, कम अमाउंट में स्केप करेंगे, और एज दे स्केप इन लेसर अमाउंट देयर वेपर formation of their vapor get reduced, and as their formation of vapor get reduced, their vapor pressure also get decreases, and as the vapor pressure get decreases, they shows negative deviation from Raoult's law, and delta H mixing is less than 0. Similarly, delta V mixing for such type of solution is also less than 0. So this is all about positive deviation and negative deviation. Now come to the next, that is azeotropes. Azeotropes, these are the binary mixtures having same composition in liquid and vapor phase and boil at constant temperature. The mixtures which have same composition in liquid and vapor phase and boil at constant temperature are known as azeotropes. Azeotrope can be of two types. One is minimum boiling azeotropes or second is maximum boiling azeotropes. Now first of all we will discuss about minimum boiling azeotropes. Minimum boiling azeotropes are such mixtures which shows large positive deviation from Raoult's law. The mixtures which shows large positive deviation from Raoult's law are minimum boiling azeotropes. Example for such type of mixtures are ethanol and water mixture, which is generally obtained by fermentation of sugars. For fractional distillation gives a solution containing approximately 95% by volume of ethanol. In this, the liquid and vapor have same composition and no further separation occur. It means the solution which are formed by the mixing of two liquids and they mix in the composition, that the composition of liquid and vapor phase get equal and they boil at same temperature. So such mixtures are known as azeotropes. Minimum boiling azeotropes are those which shows large positive deviation of Raoult's law. Example for this is ethanol and water mixture. Now come to the next, that is maximum boiling azeotrope. Maximum boiling azeotrope are the solution that shows large negative deviation from Raoult's law. An example for this is nitric acid and water. HNO3 plus water shows negative deviation from Raoult's law, so it is a maximum boiling azeotrope. So this azeotrope has an approximate composition 68% nitric acid and 32% water by mass and with boiling point of 393.5 Kelvin. It means when 68% nitric acid and 32% water mixes 32% water by their mass mixes to form a solution, they will boil at a constant temperature and that temperature is 393.5 Kelvin. So such type of mixtures are known as azeotropes. So this is all about today. Now you have to do some questions as your home assignment and I have some questions for you. These are 5 questions which you have to do as a home assignment. Read the questions carefully and do it. That's all for today. Thank you.